let's welcome our next group, NL. Can you get back
Oh,
sure.
So this is the Robotics.
Robotics, and Manny is going to present. Let's give him a round of applause.
So the NLX, these three words, they represent natural language to execution. And as you can see, the main focus will be to empower robotics through the LLMs. Here's the table of contents. Let's start. So what we did for the past few months is that we built a prototype that can convert natural language, which is user prompts, into structured validated action plans for file management. It's just a kind of like a prototype to test the idea, the higher level structure. And it demonstrates some interesting result and very cool reflections. And one of the key research insights I would like to share with you guys is a paper called Latent Codes that's bridging hierarchical robotic control. And basically it says that, well, machine language for robotics, they're very low level, and human language is too high level for them. So we need something called latent code to connect between them. And something that I use here is the method of a JSON schema. And here's the system architecture, but you'll see a clear demonstration with my demo. It's very basic, but yeah. So it's got a planner that kind of like just is the mastermind that does all the thinking, and the validator that checks if the schema is safe from the LLM, and the executor to actually do the job, like create file, write file, copy, delete, and the interface. Well, right now interface will just be the terminal. Okay, so I think it's a good time to show you guys the thing itself. Okay. I need to use this because I don't remember codes.
Are we having a live demo?
Yeah.
That is very impressive. I like live demos.
It's very basic, but I think it's easier for demonstration. Yes, all of them. Okay, so and I have to. Why is this not working?
Have you deployed it to one?
It's already deployed, and then. Sorry guys, it's gonna take a while.
Yeah, that's the thing about live demos. Sometimes they don't work.
I don't have to install the. You guys can try it out yourself if you're interested. It's on GitHub. It's inside of the virtual environment. And this line of code is on the. Hopefully this is going to work. And in the file right here is a sandbox. It's a runs and sandbox where all the running files are stored. So here's some test files that run in the past weeks, and for example, we can create a text file about Newton. But I was thinking, because the LLM itself is deployed on my laptop, it's a Llama 3. It's only like 3.7 billion, I think. It's a very tiny model. But small models actually works better for my project in the sense of that it doesn't need a lot of high level thinking or reasoning like DeepSeek or GPT-5. It just needs some very basic ability to understand our phrases and work in a constrained environment and still thinking. So just give this some time. Oh, yeah, it's done. And you can see here, the plan is that it takes the constrained files from the JSON. So it's only using a set amount of scales, so it's not going to do something crazy. And if it can't really execute the file, the scales, it will tell the user that, okay, I cannot do this, so test will abort, but this one, it seems like it worked. And let's check about Newton. Okay, it created the file, but there's nothing in it, so let's say write a 100-word essay about Newton in a new file. Okay, I hope you guys can see how this actually work, like the so how the structure is actually going to work. And yeah, let's get back to the slides. Well, as you can see, the evaluations, it's fully local, it's very private, and it's deterministic, means that it only runs what you want it to run, given the constraint of the JSON. And it's very modular. It has separated modules for you to update and then change things on to your liking. And you can add whatever skills or change the way it functions whenever you like. But the real gem to this is the evaluation and the feedbacks I received by showing this demo to other people. Is that, first of all, it doesn't have any context memory, so whenever you give it a prompt, the next prompt, you'll forget what it did, and it's not very continuous. It's not that interactive as well, because ultimately it's going to be a robot that can perform very basic tasks, and needs like a context memory to remember the environment of the surrounding and the changes. So that's one of the technical issues that we have to go through. And the second one is skill update and skill learning. Right now, it's very robust, but it's also very limited, because only the engineers or the people who's actually doing this program can update its skills, and it doesn't have the ability to, well, get better at something. It also doesn't have the ability to learn something. So that's also a very important problem, because ultimately we won't want it to be something that's so dumb it can only do what's programmed to do. It's a bit of intelligence in it, so that's something you have to expand on. And yeah, these are the two major issues we have right now. And now it comes to the future scope. The future scope comes in two parts. The first one is the software, and the second one is the hardware. As for software, we're trying to improve the architecture, because ultimately the hardware is more expensive. It takes more time to test. It also to be built. That's from an electrical engineer's perspective, but yeah. We want to make sure that the software's architecture is good enough before we actually implement it into the hardware. That's the core. So how are we going to improve the architecture? So first of all, we have to make sure it can improve its own skill sets. So as you can see in the JSON, yes, it's only a very limited set of skills that you can't really, you have to test it after you like create a new skill to see if the LM actually understand what's going on. So that's something we have to work on. And the second one is, as I mentioned, the inter-prompt memory, have to understand the entire conversation. And also it's a multi-layer validation. So this is another safety log towards the the overall validation process, as you can see, just to make sure that the thing the LM is actually doing should be impacting the environment, the real life environment, the way it should be. And lastly, we have modular APIs and multi-agent readiness, because, well, it actually comes in the age of agents. Every big company is doing that, and we also want to incorporate visual models in later development processes, so that's something we have to consider. Now comes to the robotics, which is the hardware. And the most important part is that we have to build something that can actually execute what the LLM JSONs is telling it to do. So that's a LLM to JSON to MCU, then to the actuators, like the motors and the servos. Then we have the perception integration. So right now, I'm actually planning to use the equal tag system for it's very straightforward. It's very simple. Just to telling the robot what is what and where is where. And then it's the closed loop feedback and telemetry. This is kind of like well we set it. Okay, you know what? I'm just gonna skip this. And here's the final takeaway. So this local agent that we just developed is kind of like the a tool to validate the core concept of translating our natural language into workable robots. And through this project, we learned that while there's a lot of limitations, there are a lot to improve and there will be a lot to expand on. That's it.
Any questions?
Oh, yes.
Can you see that output did it work?
Yes, I'm actually looking at it right now.
Yeah.
Just one second. Yes, let's see if it actually produced something. I hope so. Okay, news and essay. Oh yeah, there's something. Yes, it actually worked. Any other questions? Yes.
How do you ensure that it doesn't do RM route, so it doesn't destroy your system? How do you ensure that the actions that it performs are safe?
Well, so the thing I did here for this prototype is that I created a virtual environment and a sandbox, so we can only manually paste stuff in the file system, not anything that's like deep down into the system.
Okay, that's actually a very simple and effective approach.
Yeah.
But then imagine you wanted to be able to, because the more access you give it, the more capabilities it has, right? But then if you were to expand the access to all the files, how would you ensure that it doesn't produce malicious code that deletes your system or maybe downloads viruses? How would you make sure that it's not malicious? It's not harming your system essentially.
Okay, so the core concept of this this project is that we have a safety validation loop before the LLM tells the robot to do anything, because eventually we're gonna have robots in this world and they can't have impacts on humans, like physically, so that's bad. We don't want anything bad to happen. So as you can see here, we have the validator and the planner. So given the constraint of the set amount of skills that the robot can do or the agent can do, that kind of limits the malicious thing we can possibly do.
Okay.
Yeah. But we're working on research on that, definitely.
Any other questions? If no, then thank you.
Yeah, thank you.